In this video, I'm going to cover how rendering works in Fulcro. Fulcro leverages all of the mechanisms that React provides for optimizing the rendering of an application as efficiently as possible. Now, there's an extra layer Fulcro is adding, of course, and that's the data management layer. So there is an overhead with running a query. So the aspects, I guess we could write them down real quick in the UI over here, just as the query has some overhead. Then, of course, there's the output of the factories, which is essentially your virtual DOM nodes. And then React is going to do some, DOM diffing. Now, React defines a number of places where optimization can happen here, as does Fulcro. So the places where we can make things faster is we can reduce the amount of query we need to run. In terms of the factories, we can reduce the number that need to run, period. And then as far as the React DOM diff goes, we can do things like specifying stable keys and such. And these are just like the React level things you can do to make React understand the virtual DOM better so that it does a quicker job of the diff. So we're going to go through kind of how Fulcro does the rendering story, and to see that, I've placed console logs in each of the classes to show when it renders and which one it renders, if it can render more than one. So render car, render person, render the list of people, and render the route. Of course, we're making the app, and here I've substituted the optimized render algorithm out for keyframe render. So a keyframe render in Fulcro always runs the entire query, like it's the least efficient option. It runs the entire query and then renders the entire application from root. So it passes the root props to the root component, and everything's supposed to render from there. And so you can see if I delete something, save this, I get a hot code reload. Now, hot code reload always forces a full re-render of the application, so you can kind of ignore anytime you see Shadow's compile symbol pop up and then a list of everything rendering. That's a built-in feature, so hot code reload always re-renders everything, so you can see hot code changes even if data hasn't changed as far as the UI goes. So we're going to ignore that for the moment. I've added back in our make older mutation. You give it a person ID and it goes into the app database, finds that person ID's table entry, and increments their age. So if I go down here and run this particular, I'll clear the console just to make it a little clearer what's going on. If I run this mutation, you see that with the keyframe render, I'm rendering root. I then render the list, and then person 1 renders. You see that person 2 did not render, nor did any of the 6 cars that are in the display. The reason for this is React's should component update. Now, raw React, it doesn't define a should component update because it doesn't understand how you're doing your data, although you can extend the pure component class in React, and it defaults to just checking to see if the things are equal. Fortunately, we've got immutable data structures, and so from an efficiency standpoint, should component update can be super fast, because most of the components will receive not only the same value of data, the data is immutable, they'll receive the exact reference to the exact map of props they got last time if those props haven't changed. Meaning that when we have should component update check in ClojureScript, it takes nanoseconds. It's very fast. But what I'm going to do here is I'm going to go through and show you that if you were to have just like the raw React behavior where it just says, yep, it should update, that we're going to get quite a bit of over rendering here now. So we'll always get that on hot code reload. We'll always see that one happen. But now if I run this mutation again, you'll see that not only does the component whose data changed re-render, everything re-renders. And so here the only optimization we're getting at all is React's ability to then diff the DOM and the VDOM and only update the real DOM nodes that have changed. So it's still relatively fast. It's just not as fast as it can be. So that's optimization layer 1, we'll call that, is this should component update is defined for the components so that so that as we work, and we modify something, you know, deep in the tree, we get the minimal update for the renderer we've chosen. Now, keyframe render is not the default optimized render. You can override the optimized render. In fact, you can override the entire rendering system of Fulcro and put whatever you want. If you want to use preact or, you know, whatever VDOM diffing thing, or if you have your own custom way of getting this data from, you know, Fulcro's internals onto a screen of some sort, native, whatever, you can override these functions and plug in what you want for doing the rendering. It's just we provide by default the React bindings. Now, in order to make this even faster, what we said a minute ago, the two additional things we can do, well, it would be nice to skip root and list. Nothing changed in these two components. We had to go through them because we queried for the entire tree, and the only way to pick the tree apart is to pass it to root and let root pick out the thing that list needs, and then list pick out the thing that person needs, and then we're relying on should component update to keep the extra work at bay. But we'd like to avoid these two things. And there's a way we can do that, because Fulcro defines data model, and this same little bitty bit of data that we've given to each of these components gives us a whole bunch of power. So, and we haven't even gotten to the full stack story here, but let's talk about what additional power these declarations have given us all of a sudden. Fulcro knows, or can derive very easily, that this person component queries for these attributes and nothing else. It is formally declared that this is the only data that I rely on and render. It's also declared where in the database its data is. Well, again, this is immutable data. It's very quick to compare. So there's a number of things we can do with this information. So the first thing we can do is when these component instances mount, we can index them. And we actually do that in Fulcro with some hacks on the component lifecycle. So component did mount, component will unmount, do some extra work to keep track of the things that are on screen. And that's a nice constant overhead because they get mounted. They might stay on the screen, move around, whatever, then they get unmounted. Those are fairly rare events compared to the amount of updating you do in the DOM. And so if we want to look for things in these indexes, we can look, for example, for all of the components on the app that are rendering a person. And this gives me a list of, these are actual instances of on-screen React components. So we can go from a class to all. We can go from a class to any if we just need like any one of them for whatever reason. We can also go from a prop to the classes that query for that prop. And so this is a nice way of being able to, in the data model, think about the data model in this make older. The thing that I changed was a person's age. And so if I knew what components were querying for person age, I'd have kind of an upper bound of the components, right? And here it tells me it's person. You notice this is a keyword. This index keeps track of the classes by keyword, which helps with hot code reload in the indexing. The indexing tries not to store the actual classes because the classes can change on hot code reload. So if I know that person age changed, I can derive an upper bound for the things that need to be refreshed. I need to refresh all of the things that have class person in this particular namespace. And as you saw a second ago, I can find all of the instances with this guy. So, and I've already written this so I didn't have to take up time in the video, I can write a function. Now let's just leave it there. Join these comment blocks. And actually, let's just put this out here. It's a function. So I can write a function that, given a prop, would tell me all of the instances on screen that render that prop. Right? So I can do that here. I could say, tell me all the instances on screen that are rendering age. And it tells me there are two things, and that makes sense. There are two things on screen that are rendering age. And then I could map over those component instances and I could ask for their idents. So now I know not only which on-screen components are potentially in need of refresh, I know where they are in the database. I know that one of them is rendering person ID 1 and the other one's rendering person ID 2. So I'm getting closer to the point of being able to narrow this down to what might be interesting to refresh. Now there's an additional fact that I can use. I've got that list of idents in this case, but I also have the current state. Oops, that's app current state. And if you think about this, as I make someone older, right? So let's call this before, make someone older, and after. Right? I can actually look at these two, I can capture them, and since this is structural sharing, this capture is really, really efficient. I can capture the entire state of the app, but the overhead on that is very, very small. It's approximately the size of the data changed. It's very slightly larger because there's a little bit of overhead in recreating the tree for the new instance of the structural shared nested state map. But now, if I were to know all of the idents, person 1, person 2, and I've got a before and an after, I can easily see that, oh, the age that actually changed was only on person 1. Person 2, nothing changed. Still age 20. And because of immutability, this map in the before is exactly this map in the after, which means checking to see if they're equal is a reference compare. It's comparing two longs, which takes nanoseconds. So the built-in default optimized render is called the ident optimized render, and it's, if you go and look in here, here's the actual algorithm, and you see it has to do a decent amount of work because there are some corner cases that need to be covered for this to work well. So if you don't define a renderer, then it does these tricks I've just shown you. It can look things up in indexes to figure out exactly what on screen needs to be updated. And then I'm going to show you just a little bit more so I can get the idents. And then once I have an ident, let's say person ID 1, I can get the query from the person class. I can get the current state. I can get a starting entity, that's just get in on the state of person ID 1. And then I can run this function, db to tree, to get just the props for that subtree. Okay, so let's see what this looks like. If I reload so that I've got this new optimized render, you see the first initial render renders everything. And so now we're down here near the bottom. And so then if I go back to my mutation and run it, you can see that only person 1 renders. Root didn't render, list didn't render, and the subcars didn't render. Now, ident optimized render currently doesn't optimize out the subtree part of the query. The query actually runs very, very fast, typically in the neighborhood of a millisecond or less. So it's kind of a premature optimization to add a bit more narrowing to the query optimization. But this is essentially how the ident optimized render works. It uses the indexes and a before and after snapshot. If you go and look at the actual ident optimized render, what do we call it? It actually saves the prior state of the application. I don't remember what the variable's called. I don't want to search for it in the video. It actually it does this exact thing. It saves the before and after, and then the next time through it can compare the priors before, throw the before away, etc. So it can figure out which things have changed. The caveat is it also has to look in the root node to see if any root things have changed. There's a bit more dirty checking it has to do. And then it can find exactly what components to update, and then it can use this optimization to pull just the query. And then Fulcro has an additional optimization that's sort of built into the defsc components where it can target props directly to and tunnel them directly to an on-screen component without having to go through the root. And that's why you see root and list are able to be skipped here. So those are the basics of how it works. Now, there's some caveats, and there's some other reasons why I explained these things. So the fact that we have these indexes, this one in particular, right? I can find all of the on-screen components that look for a particular attribute. Is there are times when something changing is of interest to other components, and this ident optimized render won't detect that a refresh is necessary. So let's do an example of that. So the ident optimized render is only going to refresh the things on screen that it can detect have changed. Well, what if we decide we want, let's go ahead and move this make older transaction up to the person component and actually have the person component able to here we can actually use this instead of the app, and let's just quote that and unquote that, and then we won't have to move the mutation around. Oh, let's give it a label. Okay, so let's say we're clicking through, and let's say once somebody reaches 30, we want to make the background color or something of this segment yellow, right? So the idea here. Oh wait, no. That's not what I want to do. That wouldn't give me the problem that I'm looking for. In the list, what I'm trying to do is I'm trying to show a header. And what I'd like to do is in this outer segment, I want to show how many people, a count of how many people are over 30. And if you think about that, that's really not difficult to do at all. We can just compute that right here. We don't have to make that part of our state because it's, we're not going to show big long lists of people generally. You would want to paginate things. So in this particular case, it totally makes sense that I might want to derive this information just right here in place. And so this is a fairly straightforward thing to do. My count is going to be the people. We'll thread people. We can do it a couple ways. Let's just do it with a reduce. That's easy. And we'll start this at 0, and our count, our person, will have an age coming in. So we're going to walk over the people. We're going to look at their age, and if they're, well, over 30, if age is greater than 30, then we're going to increment C, and otherwise we're going to leave C alone. And so that should give us a count of people over 30. And we get back the right number. Okay, now here's the problem. If ident optimized render, I need to shrink this out of the way, is re-rendering just person 2, well, as soon as we reach 31, this number up here should have gone to 2. But the list's information didn't change, so ident optimized render won't detect that people needs to be re-rendered. So you've got two choices. The easy, super easy choice is to switch to using keyframe render and just say, you know what, we can query for the whole thing, and should component update will be fast enough, and then we won't have to worry about derived data in the UI. Perfectly valid option, and in fact that's why one of the reasons why optimized render is configurable. That might be the thing you'd like to do. In Fulcro 2 and in 3, you can also indicate which data you consider to be stale with respect to app state. So you sort of give it an explicit hint as to if something queries for this particular thing, then you might want to tell that particular thing to re-render. And so we can actually declare that in a number of ways. So one way of doing it is on the transaction itself. So in the transaction itself, we can include a second option after the transaction. There's an options map that's allowed here. And one of the things we can include in the option map is a list of refresh things. We could say refresh, and then we could literally give, and I'm going to make it obvious that this is a vector nesting thing. So we give it a list of the explicit things that we'd like to be refreshed on the screen by their data model. Now remember, the indexes can be used to go and find the things on screen that are rendering person 2. There might be a form for person 2, there might be a list item for person 2, right? We don't want to have to think about what's on screen. What we want to think about is the data model. I want to refresh anything that's looking at person ID 2 that has that live ident. And in the similar vein, we might want to specify this refresh that, well, have we queried for, in this case, person list is where our derived data is. Have we queried for person list people, right? Because if that list of people, since we're kind of looking into it, any changes to the underlying data should be considered kind of a change to the person list people attribute. And so we could list that here, person list people. And that will tell this transact that as it changes, and so let's reload this so nobody's over 30. As it changes, you're seeing person re-render each time I click this button, even though it didn't necessarily need. But now you see the number 1 follows, and the number 2 follows my transactions on these subcomponents. So this is the way you can declaratively say this particular transaction is not only affecting well, this component in this particular case, it can be affecting some other component.